Hello everyone. In last lecture, we have seen data transfer instruction and how to use different data transfer instruction and how to transfer the data from memory to register or register to memory. Now in today's video, we will see different types of arithmetic instructions used for the programming of 8086 microprocessor. Here you can see different arithmetic instructions like add, subtract, INC increment, DEC decrement, MUL multiplication, DIB division, CMP compare. So first we take add, A double D. This is addition. This will add two numbers. Numbers may be from any register or from any memory location. For example, in this instruction, that is ADC register to register 1. So what is happening in this? This ADC is a instruction, register 2 is the destination, and register 1 is the source. So the value of register 1, the value data stored in register 1. Suppose the value in register 1 is 02 and the value in register 2 is 03. Then after the execution of this instruction, what will happen? The content of register 1 is added to content of register 2 and the result will stored in the register 2 itself. So here you can see register 1 is the content of register 1 is added to register 2 and the result is stored in the register 2. The same operation can be done in between memory and the register. This is add with carry. There is another instruction add, and there is also possibility to add 8-bit or 16-bit data given in the operand field, and that data will be added to the content of the register. This is an immediate addressing mode in which data is written in the syntax itself with the instruction itself. Add AL data. This is 8-bit data. This is representing 16-bit data. So these three kind of operation is possible with this add instruction. Now next is ADC. ADC means add with carry. Add with carry. So in previous instruction in add, only the content of register are get added. But in this add with carry, ADC is add with carry. It means the content of both register as well as the content of carry flag is added and the result is stored in the register 2. See here, register 1 plus register 2 plus carry flag. All these values are added and get stored in the register 2. Same is possible with the memory, in between memory and register or memory or register. This field is source and this field is instruction destination, and this is the instruction. So in source you can directly write the data also. So here you can see data is directly written, and you can use addition instruction like this also. So these are the different ways of using add instruction. Now next there is a subtract. All those, the way of using subtract is similar to this add, and simply add a double t and add with carry. Here SUB is simple subtraction between the registers, and SBB is the subtraction with borrow. Here you can see only registers are involved, and SBB, their carry flag is also involved. So this is subtraction with involvement of carry flag. Next is increment or decrement. So what is happening in the increment or decrement? This is increment and decrement instruction. Both can be used with the register or memory. What will happen if we will use instruction increment? So what does it do after the execution of this instruction? The content of register or memory will be increased by 1. It means, suppose what is written over here, increment register. So register 8, what does it signify? Means 8-bit register. You are using 8-bit register. Here you are using 16-bit register. Here you are using memory. So increment, in this what will happen? The content of this register will be increased by 1. So here you can see +1 is written. In the same way, with decrement, the content of register will be decremented by 1. Whatever the content of register, that is decremented by 1. Next is multiplication. So you directly use MUL instruction with register or memory. Then division, then inverse division. Next, compare. So what does this instruction do? Compare register 2 and register 1. So in this, while execution of this instruction, there are 3 cases. First, if the content of register 2, if the content of register 2 is greater than the content of register 1, then what will happen? Carry flag will be 0, 0 flag will be 0, and sign flag will be 0. Here you can see what is happening during comparison. While comparing these two registers, both content are, what is happening over here? The content of register 2, and this is the content of register 1. The content of register 1 is subtracted from the content of register 2. In first case, this will be positive. So these are the condition of flag. But here, what will happen? There will be, if the content of register 2 is less, then what will happen? Then the result will be negative. You have to take borrow for performing operation. So the content of carry flag is 1, the content of sign flag is 1, and the content of 0 flag is 0. But what will happen when both registers, content of both registers are equal? Then by performing this action, the result will be 0. So in this case, 0 flag will be set. The result of this operation in this third case is 0. So the 0 flag will be set, and these both flag have 0 value. So this is the mechanism behind the comparison. So this is the compare instruction, and this work like this. There will be three cases, and based upon the result, the condition of flag, the value of flag register will be changed. Again, comparison will be done between the registers, register and memory, or register and memory. What is the difference in these two? Location, field. This is the source, this is the destination field. So these two are different in terms of field. So this is all about registers. This is all about the arithmetic instructions. Now, next, there will be more instructions, more different ways of using this. Now, after arithmetic instruction, we will discuss logical instructions like AND, OR, XOR, test, SHR. These two are shift. These two are related to rotate operation, and these are the logical operation. So we will see this in next video. Bye. Take care.